Namaste children. When you are observing all these pictures, you can conclude something. What it is, how you can apply force. Then what a force can do. What is force? Then what is friction? What is pressure? Then what is meant by atmospheric pressure? By pushing and pulling, they are applying force. Now basically all the objects will possess one property which is known as inertia. What do you mean by that? Inertia is nothing but if an object is at rest, it continues to be at rest, and if it is in motion, it continues to be in motion. So this intrinsic property of the bodies is known as inertia, and it can be changed by applying force. So applying force is by different ways, that is either by pulling or pushing or by pressing or blowing, hitting. These are all some ways to apply force. Then what a force can do? Whenever you are applying force by using different methods, for example, if you observe a potter, he will take a lump of clay, but it with water, and he will be pressing and he will make the pots of required shape. So in that case, he is applying force by pressing. Same way, see, by pushing the door, closed door, you can open. By pulling the open door, you can close the door. Same way, whenever batsman hitting a ball, the bowler is throwing a ball onto the bat. These are all what is happening in these all cases. Size and shape is changing, or the speed of the moving object is changing, or the rest body is coming into the motion condition, or the moving body is changing. The property of inertia of the bodies is nothing but force. So now what is force? What a force can do? How can you apply force? Now these three answers. Apply force is by pulling, pushing, pressing. These are all some examples, and some examples we have seen now. And what a force can do also we have seen. A rest body can move, a moving object can come to rest. Shape and size will be changed, or its moving object's speed will be changed, or moving object's speed as well as direction also will be changed, or moving object can come to a rest. So these are all what a force can do. Now force is nothing but a physical quantity which can change the property of the bodies, that is inertia. So by applying by different phase the force on the object, you can change the property of inertia of objects, or a physical quantity which can change the state, position, shape, size, or the speed and direction of a moving object, or both, is called as force. The strength of the force can be expressed by its magnitude. The SI unit of force is Newton. This is after an English scientist, and who is the father of physics, that is Sir Isaac Newton. The effect of force will change with the change in its magnitude or direction. The size of a force can be measured by using a device called as force meter or Newtonometer. Now, the main kinds of forces are balanced force and unbalanced force. If the forces that are equal in magnitude but opposite in direction, then they are called as balanced forces. Then the net force or the resultant force will be forces of equal magnitude but in opposite direction cancel each other. So the magnitude of force will become zero. So this is called as the net force or resultant force. Now what do you mean by the net force? Net force is that force which causes some effect on the object, which is also known as the resultant force. If two or more forces are acting on an object in the same direction and all the forces are added up, so the resultant force is the sum of all the forces that helps in gaining the speed of the object and it moves faster. Now for example, the resultant force in the case of bleachers, here pushing a box towards in the same direction, so the net force F is equals to F1 plus F2. So the resultant force will make the object to move. Whereas in the second case, F1 and F2 forces are acting on this box but in opposite direction. So the net force or resultant force is the difference between these two. So F1 minus F2, if this net force is equivalent to 0, then it is called as balanced force, and if it is not equal, then it is called as unbalanced force. This is invisible. Only you can see the effect of force. By seeing the effect of force and strength of the force can be divided into two kinds, that is balanced force and unbalanced force. In balanced force, resultant force is equals to 0, whereas in unbalanced force, resultant force is not equivalent to 0. This is basing on the magnitude of force we have, that is strength of the force we classified. Now basing on how the force is applied, basing on that, again force can be classified into two major groups, that is contact forces and non-contact forces. So the contact force is acting on a body by direct physical touch. For example, muscular force, frictional force, these are all the contact forces. And non-contact force, direct physical examples are magnetic force, electrostatic force and gravitational force. Magnetic force is that force which is the strength of the magnet which pulls the magnetic substances towards it. Electrostatic force is the force exerted by the charged body on another charged or uncharged body. Then gravitational force is the force which the objects will be pulling other objects towards them, that is the gravitational force. Two kinds once again, fluid force and normal force. Any force which is acting perpendicularly to a surface, either in upward direction, vertically downward direction or vertically upward direction, it is called as normal force or thrust. Then the pressure applied by the fluids on unit area is known as fluid pressure. Fluid pressure can be in two different states of matter, that is liquids as well as gases. In liquids, that fluid pressure which is acting on the body which is immersed in the fluid, it experiences some upward force, that is called as buoyant force or upthrust. Whereas in which is acting will be creating a resistance on the objects, and which is acting by the gases, it is called as resistance, air resistance or drag. Then drag acting per unit area is called as the atmospheric pressure. It is occurring in the atmosphere, so it is called as atmospheric pressure, whereas when it is applied by the liquids, it is called as buoyant force. Then liquid force is depending upon increases with the depth, whereas atmospheric force object when it is in contact increases with the air column above the head on the unit area. But by going to higher and higher altitudes, the atmospheric pressure decreases. Then Whenever it is applying some pressure, the air on atmospheric pressure, we cannot able to feel it because the pressure inside our body is equivalent to atmospheric pressure. Prepared. Now, coming to the friction. See, when the object is at rest, there is no motion. That means two forces. One is applied force and the other is frictional force. When it is acting on the body, there is no motion. So, this is called as static friction. And when a body is sliding over the other body by application of force, that is overcoming the frictional force and continues to slide on a body, it is called as sliding friction. And in between the static and sliding friction, just to make this static friction into the sliding friction, whatever the amount of force required to make this body to start moving is called as limiting friction. And whenever this sliding friction, rather than a whole area of the base area of the object, if you make it into the rolls on other surface, it is called as rolling friction. So when you compare all these things, static friction is the greatest one, sliding friction is greater than the rolling friction, and rolling friction is the least friction. Now, what is air resistance? Air resistance is a frictional force that air pushes against on a moving object. Air resistance is also known as drag. Air resistance always tries to slow a moving object. The faster you move, the greater the resistance. See, this can be felt by a rider who rides a bicycle. When you are riding a bicycle, one is frictional force on the tires of the bicycle and air resistance frictional force on the face as well as air resistance on the back. But these are all in one direction and movement of the object is in another direction. Frictional force will be in along with the air resistance. If you overcome this air resistance as well as the frictional force, you can move the object in front direction. Heavy wind, when it is blowing, if you are walking in the direction of the wind blow, your movement will become easy. It pushes you from back and you can easily move in front along with the movement of the wind. When you are going in opposite direction, the air pushes you back against, that is in opposite direction. Your movement will be in another direction, so it will be very difficult to walk. Same way, opening a parachute. Why we need to open a parachute? The surface, the greater the resistance of the air. So larger surface area gives larger air resistance. Basing on the same phenomenon, now observe all these pictures and the clipping of the slides and draw the conclusions. What are all the forces acting on the aeroplane? One, air resistance and gravity. Air resistance is on the upper surface as well as the lower surface. On the upper surface, whatever air force is acting, that is called as drag. This is the force by nature, and gravitational pull on the weight of, because that creates the weight of any object, so that is in the downward direction. These are two forces which are acting naturally on the objects. Then what we did, the object streamlined body, so the thrust and lift are created artificially to overcome this normal forces, that is natural forces, that is air resistance and gravity on the aeroplane. This lift or thrust created on an aeroplane to overcome air resistance and gravity, that enable the aeroplane to fly. And the engine and propeller also one of the combination designed to produce thrust to overcome drag in the aeroplane. The combination of these two also produces a thrust which will overcome the drag. Then the wings are designed to produce lift to overcome the gravity. This is all the Bernoulli's principle. Basic body also create thrust. This is how the wings are created to overcome the drag, to make lift, and the structure of engine and propeller combination plus the structure of the aeroplane creates the thrust artificially, and these all four will together give the lift to the aeroplane to overcome the natural forces which are acting on the force of gravity as well as air resistance. Now, how can you reduce air resistance? What are the ways? The smallest possible surface area should be subjected to the drag. Bigger the surface area, the greater the air resistance. So, in order to create smaller surface area, possible surface area for the drag, the body will be made into streamline to push against the air resistance. Then some more examples, how car travels at low speed when it travels at high speed. So the designers first they will have a test streamlined shapes in wind, seeing the bird, and they have cut the shapes into that in order to overcome the air resistance. Which shape will be suitable the best they have chosen. Same way, when you are riding a bicycle, when air resistance is more, your body below 90 degrees, that is, this is called as crouching down. So why you are crouching down? Because to lower the or to reduce the air resistance on the body, and that becomes a streamlined body to cut through the thrust. The shape deflectors will be given.